So today I want to be talking about overfitting. Overfitting is one of the really important things in machine learning, particularly training a machine learning model and deploying it live for whatever reason maybe. Now let's take this particular example, right? So let's say we want to have a machine learning model, train the model, test the model, and check its performance. Now let's say we're given these data sets where we have two classes, class 1, class 2. You can think about any sort of thing. So class 1 could be predicting whether a fruit is an apple. Class 1, class 2 could be an orange. Or if you take the example of trading, class 1 could be, let's say, a bull candle. Class 2 could be bear candle. And let's say we are given two predictors, predictor A and predictor B. So we do have one predictor here, which is called predictor B, another one predictor A, and the value goes, let's say, from 0 to 0.6 for predictor B, 0 to 0.8 for predictor A. Now, let's assume we do have like a deep learning model or a support vector machine algorithm that is going to do the job for us. Now, something that we need to be really careful of is, let's look at the first quadrant here, which is the trend set. Say we took a small portion of the data set and we do have the trend set here, and then we want to train our model. Now, you might train your particular model, and then your model might give you something like this. I'm going to draw and separate the classes and assume this is one particular model that we trained and give us this separation. All right, say it separated this, so whatever points that fall in, let's say within the orange kind of like area that I've drawn right now belongs to class 1, and anything outside it is class 2. You can see that basically if we go now to the full data set and then we were to apply this model, what you can observe is that, oh, maybe not be drawn properly, but let me do this, right? You can see that this model is going to underperform severely. So there's one section here as well, because the model would assume that anything in the orange circle is class A. So anything that is in the orange area is class 1. Anything outside is class 2. Looking at the full data set, your model is gonna underpredict because it's gonna perform severely bad. It's gonna pick. You can see these ones, these purple points, which are class 2, would be classified as class 1. It's gonna overlook some of these ones here, right? And then it's gonna pick a bunch of class 2 and it's gonna classify them as class 1. So as you can see here, there's something really important that we can see from this is that, let me draw the first thing here is, sorry for that. The first important thing is that what the sampling the training set, sampling the trend set is really important. So the way in which we sample the trend set is a really important thing, because that can undermine your whole training purpose. So you could see that in this particular case, in the small portion of data set, it looked like the classes could easily be separated. It looked like you can easily separate the classes, and even this classification is not ideal because you might say you want something like, oh sorry, you might say you want to do something like this or like this. So your model might actually have two clusters up here instead of one, right? But let's go back. Let's assume the model did this, right? So if while you separate the trend and the test set, you do have a poor sampling, so your sample is not representative of the whole data set, definitely whatever model you're gonna train on your trend set is gonna ideally or severely underperform in reality, right? Because as we observed here, the model is not actually fit for the full data set and is really, really gonna underperform. Now, something also that's interesting to see is that you might also overfitting comes in when, for example, you have a really complicated model architecture like the one we have right here, right? Overfitting. Let's assume we did have a model like this. I'm gonna draw it in yellow. So let's say we had a model that did this, right? The yellow one, and everything that is within the yellow is class one, and everything outside is class two. So let's say, let's come here and say this, and then and this. So this is model. Wait a minute. This is model two, and this is model one. All right. So let's look at model two for a minute. Maybe we can put your color here and here model two. All right. Let's look at model one, model two for a minute. Model 2 here shows us that it's much more simpler, right? It's simple model. You just drew a curve around the data set here. It missed out a bit of these points here, right? But nevertheless, model 2 assumes that anything that falls below the yellow one here is class 1. If you replicate model 2 somewhere here, right, you could see that model 2 is not too bad, right? Because it covers a majority of the green dots, which are class 1. It's true that it also covers some of these purple ones, which are class 2, but at least it captures a lot of these points here, right? These points here. So the model 2 is gonna really perform slightly, I mean, it's gonna perform half as good for the class 2, right? But the majority of the class 1 are already kind of like taken care of. So as you can see here, a much more complicated model might not be ideal, because the much more complicated model, let's say, has been highly trained, or has learned a lot, right? It's been fitted exactly to the training set. But when you apply it now to the test set or to the full data set, basically, or let's even assume that this is in a test set, but to new data, it might underperform. So this is the issue with overfitting, basically. So overfitting, you might also say that overfitting is when you have overfitting. Give me a minute. When the model is too complicated, too complex, right? You have a really complex model, and it might not be necessary looking at the data set, right? So, and then you might also say that model 1 and model 2 are actually not good models, because technically speaking, they are not fitting the data well. And maybe we need a third model. But then maybe in order to have a good model, predictor 1, predictor A, and predictor B, not sufficient, right? So maybe we actually want to have some other predictor. And how is that going to look like? So let's say we're going to 3-dimension now. We are like this and like this. So you have predictor A, B, and let's now bring a predictor C. Now, predictor C also is going to go from 0 to, I don't know, let's say 1. This one goes from 0 to 0 0.6. This one goes from 0 to 0 0.8, right? Something like that. Now, if we start drawing these dots here, you can think that maybe looking at this, the 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 you can actually create a separation, because now the predictor C comes in and allows us to separate the model properly, right? So then in this particular case, we can draw a line in uh, in 2 dimensions. So maybe you can draw a plane. What the plane is going to do, the plane actually separates the classes, right, into two. So some are above and some are below, right? And then maybe this is gonna be the best model, because then, so let's say anything that is below here is gonna be class 1, and anything above there is gonna be class 2, right? Let's assume this one was a training set. But looking at this, maybe there's a high chance that if new data set come, basically, let's say new data set comes, it's gonna fall here. It's probably gonna fall here. One might fall here, but it looks like the majority are gonna be falling somewhere here for class 2, and for class 1, a few of them might fall somewhere up here, right? But the majority could fall somewhere down here, which means this particular model, which is model to do, let's say model 3, right? So let's call this model 3. Model 3 might be the best model, right? Best model because we've actually used 3 predictors instead of 2 predictors. And maybe for this particular data set, this is what it took to actually divide the class in like to properly divide the class and make good prediction. Alright guys, so this is in a nutshell what I wanted to touch upon. I wanted to touch upon overfitting, and also the need of using good predictors to generate good models, because good models are not just models you feed to data. In order for you to have good models that can have good predictions or that are able to classify data in a really good way, you also need to have good data. You need to have data where there's a relation, you can map the relation between the input and the output. Or in other words, you can map the relation between the features and the target variables, right? Or the features and the classes. These are all different synonyms, but it all means the same. Alright guys, thank you very much. This is what I wanted to share with you. I hope you liked it, and all the best. I'll see you in some other video.